This is Math 139, Section 4.12. We'll be looking at some applications of radical functions in this particular section. And we'll be looking for square root models, first of all, that fit particular data. Again, just like we have specific formats for other types of models, right? Linear models, y equals mx plus b, or quadratic models, ax squared plus bx plus c, right? We have specific forms for each type. Here's our specific form for the square root models. We'll be using f of x equals a times the square root of x plus b. Our first couple of examples will specifically look by hand at finding a square root model given 2 points. So if I have the 2 points 0, 6 and 4, 12, and my goal is to find a square root model that contains both of those points. I'm going to start by plugging in the first one. So I'm just going to rewrite this as y equals a square root x plus b. And if I plug in the point 0, 6, y is 6, x is 0. That just says that 6 is equal to 0 plus b, or 6 is equal to b. So I now know y equals a times the square root of x plus 6. Next, let's plug in the second point, the 4, 12. Y is 12, x is 4, and I've got the 6 that we already figured out as the add end there. So let's see, that would say 12 is equal to, square root of 4 is 2, so that's just 2a plus 6. I'm going to subtract the 6. So 6 equals 2a, and a equals 3. So my square root function, y equals 3 times the square root of x plus 6. All right, let's try another one. This one was particularly nice because I had the y-intercept, the place where x was 0. That made this first one come out really nice. If I don't, I may have to work just a little bit harder. So let's look at an example of that. In the second problem, I want a square root function whose graph has the points 1, 7 and 9, 11. Once again, I'm going to start by saying, well, my model is y equals a times the square root of x plus b. And let's begin by putting in our first point, 1, 7. So 7 equals a times the square root of 1 plus b. A times 1 is just a. So I have 7 equals a plus b. It's information, it's useful information, but it doesn't yet allow me to solve for either a or b. So let's plug in the second point. Y is 11, and x is 9. So now I've got 11 equals 3a plus b. Again, useful information, but does not yet allow me to solve for a or b. What I need to do is take these two equations and put them together. So I have a system of two equations in two unknowns. You may remember we reviewed that, or you probably reviewed it way back at the very beginning in the preview chapter. This is information from beginning algebra that we did by way of a quick review, and we'll have a chance here to use it and therefore review it again. So I'm going to take these two equations, 7 equals a plus b, and 11 equals 3a plus b, and I need to find values of a and b that work for both of them. I'm going to choose to use the elimination method. I'm going to notice that if I were to multiply this top equation by -1, that would make this a minus b, which is going to add up to 0 with this positive b. So let's do that. A multiplier of -1 all the way through the top equation. Leave the bottom equation the way it is. And then just add. So 4 equals 2a, and the b's are gone. A is equal to 2. Now that I've got that, I can go back and plug into either equation. I'll just go ahead and plug in the top one because it's simple. I now know that a is 2, and so that's going to give me 5 for b. So back to my square root model. Y equals a square root x plus b. We figured out that a was 2 and b was 5. All right. This is one time when your graphing calculator is actually not going to do this for you. There's no square root model on the TI-84. And so if you are using a calculator, you'll either have to turn to Desmos if you want to use technology to help you, or you will have to do these by hand entirely. I'd like to rework this last problem in Desmos, just to show you what it looks like before we get to one of the data problems. Okay, so here we are in Desmos. And the first thing I'm going to have to do is put in my values. So I'm going to put them in the form of a table. The first point we were given was 1, 7. And the next point was 9, 11. And that's all we've got, so that's all I can do. I'm now going to ask for a regression equation the same way we always do it in Desmos. You'll note in the table the y values were y1, so I'll have to type y1. And then remember, this little tilde is the signal in Desmos that you want a regression equation. And our square root equation is a times the square root of x. Oops, and I need to make that an x1. Again, I'm using the x1 because that's what it was in the table. Plus b. And there we go. A is 2, b is 5. Just like we calculated by hand. And notice it's a perfect regression. R is 1, R squared is 1. We only had 2 points, so it did come out perfectly. If I come over here to my graph, and I'm going to change my settings a little bit so I can see a little bit further out here. Let's see. Let's just go from -2 to 15 on the x. Whoops. And on the y, I'm going to go from -2 to 15 again. There we go. And you can specifically see now, there's our first point, right? There's 1, 7. And here is our second point, 9, 11. And we've definitely got an equation that contains, that has the graph that contains those 2 points. So it's a real nice visual in Desmos as well. All right, I'm going to use Desmos again in just a few minutes. And we're going to do it this time to look at an actual application problem where we've got real data instead of made-up data. So in example 3, we're given a data table. For various years, this is the number of American Idol viewers. Vital, important data, right? It's in millions. So for example, in 2002, there were 12 million people that watched American Idol, and so on. All right. As always, we don't really like years as our inputs. Their numbers are just too big. So I'm going to say, let's pick some t values, and I'm going to let t equals 0 represent 2002, my starting year. And so this will be 1, 2, 3, and 4 years after 2002. Now, this may not, the square root model might not fit this data perfectly, but let's go ahead and start just by verifying that a square root model is a reasonable choice. We know what a square root graph looks like. If we were to plot this data, we should be able to see a sort of a curve that looks like a square root. So I'm going to come back here, and I'm going to change my data in my table. Let's see, we've got 0 and 12, and 1 and 21.7. 2 is 25. 3 is 26.6. And 4 is 30.3. All right, once again, I'm going to need to change my values. My x's, if I just go from like -2 to 6 or something, that's plenty. But my y's, I have to go up fairly large. Maybe I'll go up to 35. So I'm going to go -2 to 6 on the x's. And I'll go up to 35 on my y's. There we go. All right, so I can see the points. And you can see down here, you know, it almost looks a little bit linear up here, but not with this point. This point is what's going to tell me I'm going to have to curve up here. And I think a square root model is the best model we have. It doesn't look quadratic or exponential. I think a square root model is going to fit this better than any of the other possible models that we have. So let's do the regression while we're here. Y1, do regression, and then my square root format. A times the square root of x1 plus b. Okay. And there we go. We've got the a and the b value that Desmos gives us. And then I'm going to look over here and say it wasn't bad, right? This point's a little ways off, but the rest of them seem to fit pretty well. So the square root model's not too bad. The r squared is 0.99, which is really good. So I'm going to go ahead and say, yeah, we can use this. I'm going to jot down those values of a and b before I click off the screen. Let's keep 3 decimal places. A is 8.846, and B is 12.246. All right, so there's the A and the B that we had from Desmos. So our function would be y equals 8.846 square root x plus 12.246. And actually, if I'd like to change this and use reasonable variables, I might use n for the number of viewers. And then t was my number of years after 2002. All right. In part B, we're asked to predict, using our model, when the number of viewers will reach 38 million. So that just means n is 38. Remember that this was in millions, so I don't need to include the million in my number. So if I take 38 and subtract 12.246, I have 25.754. And I'll divide by the 8.846, giving me 2.911. And then I need to square both sides of that to solve for t. And I get about 8.476 for t. So that would be within the 8th year. So if I take my 2002, my starting year, and add 8, it looks like during 2010, about halfway through, we would reach 38 million viewers. I can actually solve that with technology as well. If I do go back to Desmos, and let's get rid of our chart here. I don't need that anymore. I'm just going to, oops, hang on just a second there, get that back. Sorry, I just used an undo. I didn't mean to get rid of the chart. I need it for my graph, but I did want to not show the points. I'm just going to get rid of it that way. There we go. And then let's also go ahead and say we wanted to know when this was equal to 38. So if I just graph y equals 38, which is actually a little bit too high, right? I only went to 35, so that's why we're not seeing it. Let's fix that. We'll go out a little bit farther. Maybe I'll go out to 15 years for the x, and I'm going to go up to 50 million viewers, give myself a little space, and there we go. I can now see that y equals 38 being graphed as the horizontal line. And there we go, there's that 8.476, the same value that we got when we solved by hand for t. So rounding that to the nearest whole year, 8 years after 2002. And we can see that again using the technology to help us. All right, the last question was to use the model to predict the number of viewers in 2007. So again, remember 2002 was our starting year. So that's just going to give us a t-value of 5. So I'm just going to say n equals 8.846, and I'll plug in 5 for the t-value. And then that just becomes a calculator problem. And I get 32.03 basically. Or since they only rounded off to 1 decimal place in the chart that we were originally given, we could just go ahead and round this off to the nearest tenth and say that's 32.0 million viewers. All right, that brings us to the end of Part A. We'll continue with this section in Part B in the next video.